In this section we're going to be looking at finding zeros of polynomial functions. We'll be using this method to find with the remainder theorem, synthetic division, and the factor theorem. Let's go ahead and get started with synthetic division. Now with synthetic division, we can also use something called long polynomial division, but synthetic division is a nice little shortcut to that. So for an example such as this, we might say something like we have a third degree polynomial, and we want to take this third degree polynomial and we want to divide it through by x minus 7. Now we don't know if there's a remainder or not. There could be a remainder, but when we're trying to find about the remainder, we maybe be able to do some sort of graphing here in a minute as well. But we have to be able to keep track of all the coefficients, and when we're doing synthetic division, it's kind of a fast way to do that. So for synthetic division, if I'm dividing through by x minus 7, the root I'm looking at is the opposite of a negative 7. It's a positive 7, so that's what goes here. Now what goes across here are the coefficients. Now the coefficients have to be in order of the highest power, third degree, second degree, first degree constant. So the coefficient in front of my third degree is a 1. The coefficient in front of my second degree is an 8. The coefficient in front of my x to the first is negative 8, and my constant is 6. Now if I'm missing any of these powers, I have to put it in 0 as placeholders. And a lot of times up above I put the third degree, the second degree, the x to the first, and then a constant. This will help me in the end when I look to see what my final solution is as well. So to use synthetic division, what we do once we have this set up, and again these have to be in descending order, is I bring the first coefficient straight down. Then I multiply the 7 times the 1 and bring it up, and then I add 8 plus 7 to get 15, so I add down. And then I do the same thing again. I take 7 times 15 is 105. And then I add down, and when I add down I have 105 minus 8, which should leave us with a 97. And then I multiply again over here, 7 times 97. 7 times 97 is 679, and that value will go up here. And then my final step would be I'd add down one more time, and I end up with 685. Getting some big numbers here. Now when we look at to see what our solution is then, when I divide, my powers decrease by 1. So what was x cubed up here becomes x squared down here. What was x squared here becomes x. What's an x here becomes a constant. And this value that's left is called my remainder. Now this sometimes could be a 0. You don't always have to have a value for the remainder, of course. It could just be 0. So when I write out my solution, what this looks like then is this is equal to x squared plus 15x. I took the coefficient, plus 97 is my constant, plus my remainder. My remainder is 685 over my divisor. And so this is what this third degree polynomial is divided by x minus 7 is equal to this value right here. Now this brings up also the idea of the remainder theorem. So let's go ahead and write out formally what the remainder theorem is, and then we'll see how it applies to this particular problem. So let's look at the formal definition of the remainder theorem. And I'm sure that this will show up on a lecture quiz, so it's a good idea to have this written out in your notes. What the remainder theorem states is that if we have excuse me, if we have the polynomial, and we'll go ahead and just call the polynomial f of x in this case. So if we have the polynomial f of x divided by, let's see, the binomial x minus c, where c is any constant, it could be positive or negative, then the remainder is f of c. Now notice that that's the opposite of what it appears here. So if this said x plus c, then what we would say is then the remainder is f of negative c. But if this is x minus c, we use the opposite to plug in here. Now what do we mean by remainder? Well, f of c means if we could just take this value c and plug it into my function, I should be able to check to make sure that my remainder is actually 685 here. So let's go ahead and take the problem that we just did, the x cubed plus 8x squared minus 8x plus 6. So let's suppose, this is an s and a p, suppose we have x cubed minus, plus 8x squared minus 8x plus 6. And we want to look at dividing that through by x minus 7. Well, if I want to find the remainder, if I want to check my work to make sure that the problem I just did was okay, I should be able to figure out my remainder by just taking my function and then plugging in a value of 7. Remember, we always do the opposite here. So let's go ahead and do that. So we'd have 7 to the third plus 8 times 7 squared minus 8 times 7 plus 6. Okay, if we simplify this, 7 to the third is equal to 343. 7 squared is 49, and 49 times 8 is 392. Now remember, when we square here, we have to square the 7 first. We don't take 8 times 7 first and then square that value. Negative 8 times 7 is a minus 56 plus 6. Okay, as we're simplifying then, we have 343 plus 392 minus 56 plus 6. And we get 685. Now notice that that is the exact remainder that I have up in this problem right here. So if I can do all this long synthetic division work and I get 685 for my remainder, and I can come down here and double check that and it verifies, then I'm pretty confident that my synthetic division was correct. So the remainder theorem is pretty nice about helping me find and verify that remainder is correct. Now the factor theorem is something that we actually have already used quite a bit, but we'll go ahead and just state it formally here. Again, this is another good thing to know for your lecture quiz. Basically, the factor theorem states, let's open up a new page here, that if we have some polynomial and these are all polynomials, these are not square roots or fractions, these are all polynomial expressions. So if f of x is a polynomial function, has to be a function, and we know that at some value of x that we plug in this value of x, we get 0 back out, and that basically means that I'm crossing the x-axis at c because my y value is 0, then what that tells me then is that x minus c is a factor of that original polynomial function. So c would be my root, x minus c would be called the factor of that. And this is kind of the reverse of the zero factor property. We're used to saying, oh, x minus 2 is a factor, x minus 2 equals 0, that means x equal 2 is a root. So we're going to be using some of these ideas when we're talking about synthetic division and then asking to find the remainders as well. Now we talked about some problems with synthetic division. If there were powers missing, we had to go ahead and put in 0 as placeholders. Let's go ahead and look at a problem where this is the case. Let's look at x to the 5th minus 32 all over x minus 2. Okay, so synthetic division. The 2 would go here because remember we always do opposite. Now I'm going to write in my powers: x to the 5th, x to the 4th, x to the 3rd, x to the 2nd, x to the 1st, and then a constant. So x to the 5th, my coefficient is 1. And then I go all the way down to this constant at negative 32. Now what I need to do in between is put in zeros for each of these values, because 0x to the 4th would be 0, 0x cubed would be 0, etc. So I'm not changing the value, but what I'm doing is I'm keeping track of the coefficients, and that's going to be important to do here. Now with synthetic division, I do the same thing that I did up above, even though I now have these placeholders. I bring the 1 straight down. I multiply. 2 times 1 is 2, bring it up, add it down. 2 times 2 is 4, bring it up, add it down. 2 times 4 is 8, bring it up, add it down. 2 times 8 is 16, bring it up, add it down. 16 times 2 is 32. In this case, I get 0 as my remainder. So now I'm going to keep track of my coefficients again. X to the 5th, 1 less power would be x to the 4th, x cubed, x squared, x to the 1st, constant, and remainder. So everything goes down by a power. So now when I go ahead and write out my solution, this tells me I have a 1x to the 4th plus 2x cubed plus 4x squared plus 8x plus 16. My remainder is 0, so I don't even include it. So that tells me that x minus 2 divided evenly into x to the 5th minus 32 with no remainder. So that also kind of tells me something about the fact that x minus 2 is an exact factor. So that also tells me that 2 is a root. So that's using the factor theorem. My remainder is 0. And again, we can double check that if you'd like to. So let's see what we called that one up here. We called that the remainder theorem. So let's go ahead and apply the remainder theorem. So the remainder theorem would say f of 2, remember we just do the opposite here, so f of 2 would be 2 to the 5th minus 32. 2 to the 5th is 32. 32 minus 32 is 0. Okay, now I have the special case for my factor theorem then. So this implies the remainder should be 0, which it was, so I know I've checked my work. Now let's go ahead and apply the factor theorem. Now the factor theorem states if I have f of 2 equals 0, which I do have in this particular case, then x minus 2 opposite was a factor. So we basically verified what we already knew. X minus 2 was a factor because there was no remainder. So the remainder theorem and the factor theorem oftentimes go hand in hand. Now when we're using synthetic division, remembering to put in that 0 as a placeholder is going to be really important. What I want to do next is I want to choose some of the homework problems that you're going to be seeing when you're working through this section, just so you can kind of get used to how they look and kind of what they're asking for in some of the directions. Now for this problem, there's actually a couple different ways that you could work it. There's kind of the hard way and the easy way. It's probably a good idea to use both methods, and that way you can check your work. So this one, again, is right from your MyMathLab homework, so you'll see directions just like these. It says use synthetic division and the remainder theorem to find the indicated values of the function. Well, the question is, do we really need to do any of that, or could we just plug -2 into this graph? Well, if we wanted to, we could just plug -2 in. We don't have to do everything else here. So let's do that first. Let's try and take the easy approach here, and then we'll explain or show how the more difficult approach, kind of the theoretical approach, also works as well. So what we're doing is everywhere that we see an x, we're plugging in a -2. So -2 to the 3rd would be -8. Now over here in this next piece, we don't take -3 times -2. Order of operations say I need to square this first, so -2 times -2 would be a +4. -7 times -2 is a +14 plus 6. And you keep simplifying. We have -24 minus 12 would be a -36. And then we'd have -36 plus 14 would be a -22. And then we have a -22 plus 6 would be a -16. So I think our answer here will be a -16. Now we could also get this answer pretty easily checking our work on our calculator as well. So a quick problem that we could do for the calculator, we could, I want to make sure I can see the original problem here. We have 3x cubed, so let's go y equal, and let's go ahead and input this function. 3x cubed minus 3x squared minus 7x plus 6. Now if you want to graph this you can, but really we're more interested in the table. But let's go ahead and have a look at this. Okay, there's our third degree polynomial. Now let's go ahead and go second table, and I want to look at -2 here. That's specifically what I'm interested in. Let's try it again, second table. Here it is. So -2. So if we scroll up here to -2, we can see pretty specifically, here's the ordered pair, -2, -16, and that verifies what I got right here with the -16. So you can do these by hand, you can use your calculator to graph these and then have a look, or you can use synthetic division. That's the advice they give us, but synthetic division is kind of the long way around on this one. So let's do this same problem. Let's use synthetic division. So when we're setting this up for synthetic division, remember we have to go in order of our powers. So I have 3x cubed minus 3x squared minus 7x plus 6. So this is x cubed, x squared, x to the first, and my constant. Now the question is, what's going to go out here? Well, when I'm talking about f of -2, that's not the same as the problems we were working up above. Up above we were given a factor such as x plus 2, and then we put a minus 2 here, or x minus 7, and then we put a positive 7 here. So we need to figure out what we're going to put here. As it turns out, we can just go ahead and use this value of a -2 here. So let's just go ahead and put our -2 here. We'd bring the 3 straight down, multiply, -2 times 3 is -6, add straight down, -3 minus 6 is -9, -2 times -9 is a positive 18, 18 minus 7 is 11, -2 times 11 is a -22, -22 plus 6 is going to be then our remainder. In this case it would be a -16. So if we had to write this out, this would be my x squared, x, constant, and here's my remainder, and that's what I'm interested in here. And you can see that this lines up with -16, which we found by graphing and by just plugging in the value. So do you have to use synthetic division for these problems? No, you don't. You can just go ahead and plug in a -2 to see what you get back out. Now sometimes synthetic division is going to come in handy when we're trying to find the zeros of a polynomial if we're given kind of a root or an idea of where to start. Now with a lot of these problems, I think it's a good idea to go ahead and graph these if you can, and not all of them will the graph make sense, but a lot of times the graph gives us a pretty good idea or a good start on, something that might give me a hint as to what's going on with this problem. So for this next homework problem, we're going to be given slightly different directions. So it says solve the equation, and again this is an equation because I have this equal sign right here. So solve the equation given that 1 is a 0 of that particular polynomial. Now when I talk about my solution set, I already know that the number 1 is part of that, so I need to remember that they already told me that 1 is part of my answer. Now if 1 is part of the answer, I need to be able to find the other answers, or the other solutions. So what I'm going to do is I'm going to graph this. So let's go ahead and hit y equal, and let's look at x cubed, x to the third, minus 13x squared, plus 47x, minus 35. Let's just graph this and see what's going on. We might have to adjust our window. Now when it says solve the equation, basically it wants to know the values where this crosses the x-axis. So let's pull this across. I can see that it crosses once, twice, 3 times. These are the zeros of this function. So I think my answers are going to be 1, 5, and 7. So let's go over here to my table and see if we can see these same values on the table. Here's 1, here's 5, and here's 7 where I have all the zeros. So I can graph this. I don't have to worry about the long polynomial division if I don't want to. I can see my solutions pretty clear right from the graph. Now the graph doesn't always work, however, so we have to be careful that we actually know how to do these by hand as well, Because what if my answer was a fraction or a decimal? If that was the case, I'm not going to get my answer from the graph. However, this one I can. So let's go ahead and pull these numbers, and then let's see how it verifies with using synthetic division to find these values. Okay. So this is the output from my calculator. And let's see how these compare. So here's a solution, here's a solution, and here's another one. And again, this looks like x equal 1. This one looks like x equal 5, and this one x equals 7. Now it could be a decimal, you know, maybe it looks like it's crossing, but we can verify that over here. So here's x equal 1, x equal 5, and x equals 7 as my solutions or my roots. And I know this is where they're crossing because these are where my y values are 0. So up here my answer would be 1, 5, and 7. That's the values that I'd put in here. I don't need to put x equal, I just put in my numbers 1, 5, and 7. Now, how would you do this by hand? Because again, graphing won't always do this. Nice little integer solutions. What if they're decimals or fractions? So what we would do is we would start with the idea that we know 1 is a 0 of the function. So the first step that we're going to take is we're going to look at x cubed minus 13x squared plus 47x minus 35. And I'm not going to worry too much about the x equals 0 thing right now, or sorry, the equals 0 thing. I'm going to worry about that 1 is a 0. Well, if 1 is a 0, that tells me that x minus 1 must have been a factor. So 1 is a 0, which says that x minus 1 is a factor. Then I can use synthetic division on this. Well, x minus 1, I do the opposite. And then I write out my coefficients, 1, negative 13, 47, and negative 35. I always write my powers up above just to remind me x cubed, x squared, x, and constant. So what we have here then is I bring the 1 straight down. 1 times 1 is 1, add down, negative 12, multiply up. 47 minus 12 would be 35, multiply positive 35, and my remainder is 0. So we have going down by a power, x squared, x constant, and since my remainder is 0, that tells me that x minus 1 is indeed a factor. So what I have here then is that x cubed minus 13x squared plus 47x minus 35 equals 0. Factors into x minus 1, that came from right here, and then my remaining factor comes from right here. That's going to be x squared minus 12x plus 35 equals 0. Okay, so now when I'm looking at this, I need to find those other values. We already know they're 5 and 7. Where do they come from? Well, as it turns out, I can actually factor this into a product of binomials. So whether you learn to use the AC method or the reverse FOIL method, either way, this factors into x minus 7, x minus 5. Now if you weren't sure how this factored, you could graph x squared minus 12x plus 35 and see where it crosses the x-axis. And then from here I use the 0 factor property and I say, oh, x minus 1 equals 0, x minus 7 equals 0, x minus 5 equals 0. And again, this is called the 0 factor property. So here, to solve, I'd add 1 and I'd get x equal 1. Add 7, x equals 7. Add 5, and I'd have x equals 5. So my solutions then, by working this by hand, would be 1, 5, and 7 in order from smallest to largest. So we saw many different methods here. We saw graphing. After we graphed, we could identify the points of intersection on the x-axis just by visualization, since they were nice integers. We also looked at the table. And then we also saw, given one root, I could use synthetic division to find my remaining factors and then factor again using the reverse FOIL or the AC method. So some of these problems can get a little bit involved. One thing I would recommend right away is to graph it. Get an idea, get a visual. How many roots am I looking for? And it might be a really straightforward problem and where you get nice integer solutions, or it might be a little bit more complicated problem where I don't get integer solutions. Now this next problem is a prime example of being able to graph, but the graph might not be helping very much because I'm not crossing at an integer value. So this kind of shows why graphing is useful, kind of helps me find how many roots I'm looking for, but it doesn't really help me find the exact roots in fractional form. It can help us check our answer though. So to get started with this one, as usual, I still recommend we graph it even though I'm kind of concerned that I have this root of a negative 2/3, so that tells me right away I don't have integer values that are the easy ones to find. So let's start by graphing y equal. We have 18x cubed in this case to start with, so I have 18x cubed plus 15x squared minus x minus 2. And let's go ahead and graph that. Okay, that didn't graph right, so let's go ahead and try 18x cubed again. My calculator kind of froze there at the end. Plus 15x squared minus x minus 2. I just want to do a quick graph and have a look to see what's going on here. How many roots am I looking for? Because this is a third degree polynomial, there could be 0, 1, 2, or 3 roots. It just kind of depends. Now, this graph, it's kind of hard to see what's going on, so I think there's a little curve in here, but I want to kind of spread this out, so let's go ahead and click Window. In my x min and max, let's say -5 to 5. And you can make up different values here just to kind of see what's going on. And here I'll change this from -10 to +10. I should see a little bit more of that curve right here by the origin. There it is. Okay, so now when I'm counting this, how many times it crosses, it looks like it crosses, looks like it touches once here. And then it definitely crosses over here. So I want to blow this up a little bit more. Does it touch and turn, or does it actually cross and go above? So let's hit Window, Y max. I want to put this up to, let's say, the number 1. So I should really get an idea of what's going on here. I think it goes over the top and crosses. So I think we're going to get 2 answers here. So I'm thinking we're going to get 2 that are negative and one that is positive. And again, it's really hard to kind of decide what's going on there without getting a better look at that graph. So I'm going to even change my y min to a -1 and graph again. Let's see. Well, I can, oh, you definitely see how it went up above, but when my scale was really small, it was hard to tell, but I think we're going to get 3 answers. We're going to get 2 negative numbers between 0 and -1, and then we're going to have this one positive number that's between 0 and 1. So that kind of gives me an idea of what's going on for my number of solutions. I should definitely have 3 solutions. Let's go ahead and pop this into our lecture. It doesn't really help me with finding these solutions though, because they're definitely not crossing at integer values. So this is a case where, you know, the graph is helpful because it's telling me I have 3 solutions, but it's not really telling me what those solutions are because they're not crossing at integer values. So I know from here I have 3 solutions. 2 of them are going to be negative, between 0 and -1, and I have this one right here that's between 0 and 1. Now one of my solutions is -2/3, so I need to remember to write that down right away because it is given. Now I kind of think this is the -2/3. I could be wrong, kind of depends on my scale, but then I'll have some other negative number, and then I'll have this positive value. And you can actually go into on your calculator and you can find those points of intersections. I think on your calculator you would go to second calc and you would go to 0 because you want to find out where it crosses the x-axis at 0, and you'd say left bound. I'm going to go ahead and find this positive one. So here's my left bound. I'd hit enter. Right bound, I'm to the right, and then hit enter one more time. So it's telling me that this value is 0.3 repeating. 0.3 repeating is 1/3. So I guess I could find that as my solution here is 1/3. And then I could go in and find my other one using the same method. I think this one's negative 2/3, so I'm going to try and find this one. So I'd go second calc. Again, I'm trying to find that 0. Now this one's going to be tough. I'm clicking to the left here until I see that star again. So here I'm definitely to the left. So the problem is they're so close together that I have to make sure. So here I'm to the left, or at least I hope I am. Here I'm to the right. And then, yeah, I think it's covered in there. Boy, that's really close. And I'm going to hit enter one more time for my guess. There wasn't enough of a sign change is what this is saying. So I haven't been able to get close enough to figure out a left and a right point on that where it will find that sign change right here. So let's try that again. I think I might have been hitting just the top part. So let's go to 0. So there we're definitely to the left of this point. Now we're to the right one more time. Oh, negative 1/2 would be this point then where it crosses. So I can find that. So this point right here is a negative 1/2. So if you're good at converting your fractions from decimal form to fractional form, it wants your solutions in fractional form. So I guess you can go in and verify your solutions. But let's go ahead and see how you would do this by hand with starting with some synthetic division. So we have negative 2/3 is our value here that we're checking. My powers are 18, 15, negative 1, negative 2. Remember powers, x cubed, x squared, x, and constant. So I'd bring the 18 straight down. Now a negative times a positive is a negative. 2/3 of 18 is negative 12 then, because I have a negative 2/3 times 18. Now if you need to use your calculator, that's fine. Just take negative 2/3 times 18. Now we're going to add down 15 minus 12 is 3. Negative 2/3 times 3 is a negative 2. Add down to get a negative 3. Negative 2/3 times negative 3 is a positive 1. Add down negative 2 plus 1 is a negative 1. Oh, wait, I should have a remainder of 0 here, shouldn't I? Because I knew this was a root. So let's check this ending part here again. I think I made a mistake. So negative 2/3 times a negative 3 is going to be a positive because a negative times a negative is a positive. 2/3 of 3 is going to be a positive 2. Negative 2 plus 2 is 0. So a remainder is 0. Now, decreasing powers, x cubed goes to x squared, x constant in my remainder. Okay. So what we have here then is my original problem, 18x to the third plus 15x squared minus x minus 2 equals 0. We knew factored into x plus 2/3 because we were given that negative 2/3 was a root. And now we have this other factor, 18x squared plus 3x minus 3 equals 0. So if we can, it would probably be nice if we could just factor this by hand. And I see that we have a greatest common factor of a 3. So I could pull a 3 out. So I have x plus 2/3. I'm going to go ahead and pull a 3 out to make my work a little bit easier here. So that would be 6x squared plus x minus 1 equals 0. Okay, and again I have that 3 out front. Now it's my hope that this factors, and I believe it will, into, let's see, 3x times 2x is 6x squared, plus 3x minus 2x is a plus x, negative 1 times 1 is a negative 1. Now I use my zero factor property and I take each one of these and set it equal to 0. Now the 3 I divide through by 3. There's no variable there and you can see 0 divided by 3 is 3. so I can just ignore that one. And as I solve each of these, here I'd subtract 2/3 from both sides, have x equal negative 2/3, add 1, get 3x equal 1. Here I get that x equal 1/3 that I have for my graph. Here I subtract 1, divide by 2, I get x equal negative 1/2. So these match. I get x equal, we'll go in order from smallest to largest, negative 2/3, negative 1/2, and 1/3, which is exactly the list I had for my graph. So again, doing these by hand or graphing, there's two good options there. I really recommend that you graph them first to kind of get an idea of what you're looking for, and then kind of take it from there. Okay, so for this one, they want us to show, using synthetic division, that 5 is a root. So which one of these would set that scenario up? Well, if 5 is a root, the 5 would go here in these positions, and what we need to do is figure out which one works so 5 is a solution. Well, if 5 is a solution, that means the remainder has to equal 0. So as I run through these, the remainder of this one would be 0. The remainder of this one is not equal to 0. The remainder of this one is, what, 2,500? And the remainder of this one is a negative 1,000. And in this one over here, it was negative 1,070. So this is the only one with the remainder of 0, so this would be our correct answer. Okay, but you're going to have to input this value of 5 and then this value of 0. Now the second part of this problem says the height h of the rectangle of the box then is 5 inches. So because that's a 0 for part B, I would use 5 for my solution because I've shown that that's a 0. Okay, this next one again, we'll just give a quick setup. And we've actually seen this one quite a bit. It says, use the table to determine a solution. Well, we've already done a lot of tables when we were using our graphing. So this tells me right now, because y is 0, x is 3 is my solution. So which solution can be determined from the table? The 3 is definitely a solution. It says, then solve the polynomial equation. Well, you can use synthetic division and see what you have remaining as a factor and try and factor that like we did in the above problems. Or I can graph this on my calculator and get a larger view of this table and find my other solutions that way. So that's another type of problem that you'll be running into. Now the last problem that we're going to be looking at is another application problem, and I just want to give you a quick overview or a start on how you might want to consider working this last problem. Okay, so go ahead and take some time to read through this one. This says, use synthetic division to show that 2 is a solution of this equation. Well, if we wanted to use synthetic division, that would mean for part A, I would pull that 2 out front, and I would go through my synthetic division, 10, negative 11, 13, and negative 62. Or sorry, negative 62, not 16. And when I go through synthetic division, if it is a root or it is a solution, my remainder should be equal to 0 here. So I need to go through and verify that. That's for part A. In this one, they're not being very tricky, kind of like the previous one to this. They use their solution in that box to get an answer here. But for part B, again, this was part A. For part B, it says use the solution from part A to solve this problem. The number of eggs, which is f of x, in a female moth is a function of her abdominal width in millimeters modeled by the equation below. So f of x is the number of eggs, and so we want to know what is the abdominal width when there are 122 eggs. Abdominal width when there are 122 eggs. So if we wanted to set this up, I could try and figure out 10x cubed minus 11x squared plus 13x plus 60 equals 122. I want to know when this equals 122. And try and solve this. And it wouldn't be an easy thing to solve, but however, they said use the solution from part A. So if I take my solution from part A, which was 2, and plug it in here to just go ahead and double check, I get 2 cubed is 8 times 10 is 80, 2 squared is 4 times 11 is 44, 13 times 2 is 26 plus 60. So 80 minus 44 would be 36 plus 26 plus 60. So this would be 30, 50, 62 plus 60 was 122. So the easier way to solve this is use their hint. And basically then our answer for part B would be 2 then. Good luck on this section. It's actually pretty straightforward. And remember, you have more than one way to solve these. You could graph and kind of get an idea of what your solutions are or what you're looking for, or you could also go ahead and use your synthetic division. Either way is fine. If you have questions, please bring them to class, stop by the Math Center or my office. We're happy to help you out.